Fantastic. So our next presentation is going to be from GNext. Prior to that, though, we do have, is anybody using the app? I guess we're supposed to be flipping this. And just noticed that some of these times are off, so give me a second. 16. You got that, John? Thanks. Yeah, so what those are for is if you'd like to track your session attendance on the C-Event app, that's what you're going to use those codes for. So also they are noting in here that it only works for the first 15 minutes the session starts until the session ends. And it does say further directions on tracking course attendance are available in the C-Event app under the IHEEP 2023 event or in your printed program. So with that, I'm going to introduce our presenters here. We have Abraham Lama and Russ Ellis. So Abraham is a leading expert in the application of computer vision and AI for automated civil infrastructure condition assessment. He is a CEO and co-founder of GNext Labs, a company that develops and deploys innovative solutions for the inspection and maintenance of bridges, dams, and other critical infrastructure. Abraham holds 2 MS degrees and a PhD in civil engineering from Virginia Tech. Also, his research has been published in top academic journals and conferences, and he has received numerous awards for his work. Abraham is passionate about using technology to improve the safety and reliability of our infrastructure. He's also a strong advocate for the innovation and collaboration, and he is committed to making a positive impact in the world. Russ Ellis, next, as a software entrepreneur, 30 years experience in building and operating impactful technology companies in the United States as well as the UK. In his role with GNext, Russ is focused on delivering the best possible technology and support to the growing infrastructure asset inspection market with the GNext platform. So with the addition of artificial intelligence, the opportunity to remove the bottleneck in asset inspection is becoming a reality, and GNext is taking a leadership role and bringing these capabilities to market. So with that, it's my pleasure to turn the time over to you.
Thank you. Good afternoon, everyone. It's great to see everybody here, and I can really appreciate the fact that you have hung out all day. There's been a lot of information, great information presented, and I'm glad you're here with us today. And by the way, there's extra credit for this code with this presentation, so you'll want to capture that and be able to utilize it. The title of and the focus of our discussion today is transforming asset inspections using drones and artificial intelligence. That sounds like a whole lot, and it really is. There's a lot to unpack in that. And what we'd like to do is kind of walk through and just show you some of our use cases that we found and what we're doing with this. We've got 2 use cases to discuss today. The first is a concrete bridge inspection, and the second is a concrete dam inspection. And you can see there's a bit of a theme here. And it's not dam, and it's not bridge, it's that concrete, right? So we are, in our first AI catalog, we focused on concrete structures. Our built world is full of it, as you well know, and you work with it every single day. The way we're going to approach this is discuss in these use cases the data collection and how proper data collection is so important. That's been drilled into us all day and all week. We'll just show some visual examples of how this data was collected. Then we'll talk about the digital twin via photogrammetry, and this is utilizing the proprietary GNext photogrammetry engine, and all the technology that we're going to just disclose and show you today is all GNext. Next, we'll talk about our AI-based analytics. So we're applying AI to these feature detections, these defect detections. We'll talk about it and some of the great underlying tools that you can utilize with it. And the benefits will be pretty self-evident, but we'll still drone on a bit about that as well. All right, so first up is our concrete bridge inspection. So what we're seeing here is a bridge. This was a project that we did with B&N. This is a large scale or a concrete bridge, obviously. Each one of the red rectangles indicates where an image was collected during this. We're going to run a couple of short videos here. The data was collected utilizing a Skydio 2 with 3D scan. You can see it was able to get all the nooks and crannies all the way under here and really get to a lot of the underlying detail and data. 12 megapixels never looked so good. Next, we're going to talk about the photogrammetry aspect of it. So we're looking at we'll see a 3D model here that was processed in the GNext engine. And as we go along, we'll see the user interacting with the 3D model, getting up close and personal and looking at these cracks. And there's some very significant ones. As a matter of fact, the data collector told us later, he said he didn't see any of these big cracks and spalls. He couldn't access them without rope access. So they weren't evident to him. And when he saw it, he was really blown away. See some quick analytics being gathered here. And any place that you want to be able to explore more, double-clicking on the 3D model gets you to that most important underlying image that exists. And in this case, it's highlighted in the lower right-hand corner. That's the image that we're looking at, and all the others that have a view of that spot are adjacent to it. So you're able to get quickly a good feel by looking at the 3D model as a reference, being able to get to that underlying data. All right, Abraham.
Thank you, Ross. So now that we have all of this data and the infrastructure has been digitized, we can train AI algorithms to help them find, quantify, and track the changes over time of these defects, right? So what you're seeing right here in the screen is our system with the with the 3D model created from photogrammetry, and then all of the AI outputs and defects found by the AI, how they are located in the 3D model, how the quantification was detected for each of the defects. And then we're going to see other deliverables that can be presented or produced out of these results from the AI. So first, we're going to see, this is the 3D model created from the drone data. On the left, you can see the defects that were found by the AI. In this case, for this particular bridge, only cracking, spalling, and efflorescence were found. However, the AI we developed for concrete can detect exposed rebar, spalling, efflorescence, vegetation overgrowth, and we are continuing developing that catalog for concrete. Here, the mouse or the user is just putting the mouse, using mouse hovering on top of the defects, and then you can see the quantification of these defects. So I'm going to go back for a second, just in case you miss it. So the user is going to zoom in to those particular cracks, and then they're going to hover on top of the crack, and the system will show what is the average crack width, what is the length, what is the max crack width, what is the ID of that crack. So as the mouse is hovering that defect, you can see all of those information. Now, because everything is geolocated, we can track those defects over time. So if you do this, again, next year, we're able to tell you, hey, this crack grew by X percentage, or by 10 feet, or the crack width increased by 10% or half an inch. All of those can be tracked over time, and we're going to show you some examples later on in some slides how all of this helps reveal some patterns and interactions between crack, efflorescence, and spalling, which typically there is a connection between them. So now that we have found those defects and we have quantified its properties, that's great, right? But you're still bound to create the deliverables that you have been delivering for quite a while, and that you're required by your customers, which typically is a CAD drawing of the defects in the infrastructure. So these AI outputs can then be vectorized, and they can be used to create this CAD drawing. What you're seeing right now is a CAD software, in this case, Autodesk, but it could be open in Bentley or any other CAD software system, where the AI produced these CAD drawings in a DXF open source format that use the imagery from the photogrammetry and the AI results to then produce the drawings of all of the defects found in the infrastructure. So I'm going to play the video. And you can see this is a CAD drawing. On the left is the legend of all of the defects, again, created automatically by the AI. On the right, you have a summary table of all of the defects, saying what is the amount of cracks, what is the total crack length, amount of spalls, et cetera, et cetera. So we're zooming in. As part of the CAD drawing created by the AI, you also have a base image. So not only you get the CAD drawings of the defects, but you also get a base image that corroborates the CAD drawings. So that way you can validate that the cracks that we're marking in the CAD drawings are actually cracks in the infrastructure. Here we're moving now into spalling and honeycombing. And all of the defects in the CAD drawings are organized in layers that, again, allow the user to make their edits, to adapt it so they can then deliver the final results to the customer. And again, all of this is being visualized in Autodesk, so pretty much any CAD software system can use this deliverable in such a way. From our customers, what we have heard is that this reduced their time of more than 90% in producing the CAD drawing deliverables for their customers. Now, something that is also critical for the inspection is quantifying and producing a total quantification of defects. So the AI also produces these table sheets with all of the quantifications. So if you need to know what is the total area spalling, because you're doing a repair and you need to do an estimation of it, all of this is already included in this table that you can use for those estimations. And this is done for any of the defects found by the AI, which again, it covers cracks, spalling, efflorescence, vegetation overgrowth, and exposed rebar as of now.
So Abraham, if I were out in the field and needed to access that information, how would I do it?
You can just open your phone with an internet connection, and you can access all of that information on your phone. So if you need to analyze, okay, where is the defect that I wanted to find, that I wanted to analyze in the field, you can visualize it there. If you want to know how you're going to get access to that location, you can figure out there. So it's information that you have available both in the office and in the field.
Thank you. I make a great shield, don't I? All right, let's talk about some of the benefits, the reduction of risk. We heard from several speakers about some of how the high-risk nature in bridge and various infrastructure asset inspection there is to the inspector. Deaths and great injuries. So what we're talking about is the ability to reduce the amount of rope access and the amount of hazardous duty for the inspector. And that relates directly to reduction of costs, as well as speed of delivery for that assessment, improved asset documentation and the ability to watch that over time, quantifiable and trackable metrics, and then most of all, the ability to see change over time and how that asset's performing as it's being monitored. All right, number 2 is a dam inspection, and this is done in collaboration with Stantec. This was a large-scale dam, 13 bays. We're going to look at the data collection. Again, spoiler alert, this was collected with a Skydio 2 with 3D scan. There were about 12,000 images that were collected for these 13 bays, and we're really getting a great sense of how that data was collected. All the nooks and crannies were accounted for, and I'm pretty sure that drone sustained no damage in its collision avoidance capabilities. The great thing about being able to visualize how that data was collected is understanding that over time, you get back to the office and you see, man, there's a gap in this spot. How am I going to deal with that? So the ability to understand that and identify future capabilities and future SOPs. Next, we're going to see the underlying result of the photogrammetry. And again, the ability to navigate through the model, being able to see all of the specific areas of defects. And this is really helpful in understanding, there are 3 bays out of this that we really need to send somebody on rope access. We don't need that in every one of these bays. Again, the ability to reduce risk. Seeing some more of this efflorescence and the underlying cracks that caused it, and being able to make measurements, sub-millimeter in this case, directly onto the model. Another quick analytic gathering. and off we go.
So, going back to the AI applications, right? In this case, being used for another concrete structure. In this case, the 3D model was then transformed into cross-sectional views so that it resembles the traditional drawings that the user or that the client needs to have available, right? So in this case, we produce, or the software produces cross-section of the 3D model, and then those are being used to then visualize, again, the AI defects found. In this case, in the damp, we're gonna see other types, not only cracking, spalling, and fluorescence. In this case, the user is, again, turning each of the layer on in the sense that if the user wants to see the cracks only, or the cracks and the fluorescence, or all of the defects combined, which in the next slide, you're gonna see how it could potentially be useful because it can help uncover patterns about the relationships that they have together. So in this case, if the user hover on the fluorescence, it will tell them what is the ID of that efflorescence, what is the area, and same with spalling. In this then other scenario, we can see also the vegetation overgrowth that was being shown in green. Going back then to the final deliverables, right? Then again, the AI, the results of the AI is then being vectorized and then produce a CAD drawing that can be opened in any of the CAD software. 1 second. Excellent. And then going back to this here, we're going to zoom into a section again, just to show that pattern that I was talking about, which seems like the video is stuck. Yeah. Well, the video is stuck, but it was going to zoom in the center where you can see how cracks then turn into spalls and then go back to crack, and then turns to spall, and then go back to crack. Or then how the efflorescence grow from spalls or from cracks. Like all of those patterns are visible from these outputs, which, I apologize for the issue, but it seems like we were able to show you today. But this technology then, we hope by continuing to doing projects like this, we hope to be able to uncover then how the defects evolve over time, and then develop analytics that will help us then predict how these defects will evolve over time.
All right, a little bit of repetition here, but you can really understand all of the benefits that are listed here. One that I'd really like to talk about is the change over time analysis, and the ability to, next time that this is done in another year or another 2 years, the ability to understand that cracks have increased in a certain bay by 5%, efflorescence by 7%, and I'm just throwing out these numbers. Spalling is increased, and all the different combinations of how these defects interact with each other. And then at that point in time, we're really getting into that predictive analysis capability once we gather this data. And it's not just dams and bridges, but a whole litany of other areas of concrete areas for inspection, and that's what we're focused on with this iteration, this catalog. We've got a couple more catalogs in the works to apply for other asset types as well. And with that, I think we just came in under the wire. Any questions? Yep. Open to the floor. Taking numbers.
Great question. So it depends on the use case, right, and your needs. So if you're using ground control points, which we're using the projects, then yes. If you're not using ground control points, they're geolocated, but they're not as accurate on the geolocation. But then model to model, they're aligned automatically, so that is something that we can still track from it.
Working? Oh, it is. Can you link the locations on the model to the original source imagery so you can go back through time and see the actual images that were used to construct the model?
Correct. You just double click any location and it will bring out images that are looking at that location.
Keep those questions coming, folks. We'll be here all afternoon. Yes, we're prioritizing it based on customer demand. Concrete structures were the highest. Do you have a particular interest?
Steel, timber.
Gotcha. Absolutely. Love to chat. Love to chat with you about what your requirements are, and you know, we're very interested in exploring how we can work together on that.
What about sealed cracks? Can you detect those and track those over time?
When you say sealed cracks, where they've been repaired,
Where they've been like either like a flood seal or like an asphalt strip seal kind of thing, or epoxy injected. Can you track those types of cracks currently, or would you have to develop that?
So right now we're just tracking cracks that are visible in the optical data. We're not going further on the classification other than classifying it by the sizes, like depending on the width and the length. But the potential, if it is something that can be visually seen on the images, there's something that can potentially be added to the classification of the cracks.
So I got two questions. One is do you have minimum requirements that you have for the quality of the imagery or controlling for the quality of the imagery that you're taking into the system to help to control for that? Minimum sensor requirements, focal distance, offsets, that type of stuff. And then the other question I have is, how much does graffiti mess with your algorithm? Have you been able to defeat the pain of graffiti in the automated crack detection?
Could you please repeat the second question?
Graffiti, spray paint, people
Oh.
like to tag bridges, and that messes. Everything I've seen with automated crack detection, when the bridges are covered in spray paint, it really drives traditional inspection crazy as well. So I just was curious how if you've been able to solve that problem, or if it's the problem that still exists as it always has.
Great questions. So going back to the first question, I apologize for that. Could you please repeat that one?
Do you have minimum standards for
Yes.
the quality of the pictures?
So we provide SOPs typically with the customer about what hardware and parameters should be used. However, if those are not available, we work with the customer to see if they can do the application according to the hardware, right? Because you may not have a specific drone, but maybe if there's something that you could do with another drone. So we work with the customer on those parameters. So our system works we're drone and sensor agnostic, and that's why I'm saying that. So we can work with pretty much any drone. However, it is important to collect the data. Like if you cannot collect data below a bridge, you won't be able to get the data from below the bridge, right? And the outputs. Now, to your second question, it's not only graffiti, right? Like we have seen for dams where water dripping might look like a crack, but it's not like crack, right? There are many things that look like crack that can trigger the AI. So what we do is we're continually developing it. So the more examples of those we add to it, the more advanced it is to it. So AI is not going to be 100%, but as we continue using it more and more, it's going to be more and more reliable, right? So up until now, from what we have been able to develop, we're saving more than 90% of the time of the engineer. So maybe in the graffiti and in the use cases we have done, it doesn't come to mind about how it behaves on graffiti. But that is something that if we see it and the customers tell us, we would immediately work on including that in the pipeline for the AI. We're constantly fine-tuning it.
Great questions. Anyone else? Thanks very much for being with us today. Greatly appreciate it.